Oh,
I just
no. I totally understand. I mean, I actually it brought back some memories of my when I was in school in Peru when a friend didn't perf well he didn't perform well, he would like be quiet for like hours. So you're totally fine, totally fine. So which hypothesis involves equality?
Isn't that the null hypothesis?
Ye-
Hold on, let me
Yeah, yeah, the no that's a gives equality or provides equality.
Oh, because it's stating what is the fact, or like
Mm-hmm.
what's assumed to be true, right?
Yes.
Mm-hmm.
Okay.
Okay, this.
hang on. Um,
Sure.
I was pulling up my notes. Which one did you say?
The null
Oh, okay.
hypothesis?
No hypothesis. Okay.
Um, oh, okay, because it represents a status quo.
Mm-hmm.
Yeah.
Yes.
All right, sorry, I may be slowing you guys down a lot
No,
today.
That's
no,
fine.
you're fine. You're fine. Let's see. Remember that the p-value is the probability of obtaining a sample statistic at, at least as extreme as the one that was actually observed. When computing the p-value, which hypothesis do you assume to be true?
You assume the null hypothesis is true, right?
I believe
That's what I
so.
would say. That, yeah.
Yes, assuming that the null hypothesis is true. That's what I have in my notes.
Yeah, I just read that
Okay.
too in my notes, so
Um,
I think we're good
mm,
on that.
okay, p-value. Yeah, it's assuming that the number. Yeah, you're right. You guys are right. Null hypothesis.
So
Okay.
the
Yes.
post-null hypothesis is, how do you even read that? Mu equals 10?
Yeah, mu equals 10. Uh-huh.
Which of the following represents the alternative hypothesis for a two-tailed test?
Isn't it the does not equal
Yeah, because I think the other two are both.
Yeah.
one-tailed?
Well, wait.
The greater than and less than are one-tailed, right?
Yeah, those are
Mm-hmm.
one-tailed. And so would it be the bottom two?
No,
Or,
it
oh no,
just
just
be the
the
one.
alternative. Yeah, okay.
So the mu is not equal to 10?
Yeah.
Yeah,
Okay.
okay, cool.
Okay. Which of the following represents the alternative hypothesis for a left tail test? Huh.
It's the
Less than, right?
is that what that is? Yeah. I can never tell.
I think so. Well, unless I wrote it down opposite, but I
Yeah,
think
it's
that's right.
the one with the smallest end on the left is the left-tailed.
Yeah.
Also, is left tail will be less.
Mm-hmm.
Yeah.
Which one is that one? Is that the one with the?
That's the one with the point going towards the mu.
Yeah.
Oh, perfect. Okay, so that will be the first one on me, I guess.
Yeah, me too.
Okay. Perfecto.
So 7 would be the opposite. Would
Yep.
be greater than.
The mu is greater than 10.
Mhm.
So with the thing pointing to 10.
Yep.
Yeah.
Okay, perfect, perfect. Okay. Okay, Okay, remember that we determine the outcome of a hypothesis test by comparing the p-value to the level of significance or the A. I mean, that's the alpha. I think that's alpha.
Yeah, it's
Use this
alpha.
information to answer. Use this information to answer the next two questions. Which relationship would result in failing to reject the null hypothesis?
So
I think
I think
when,
it's the first one.
when P
Yeah,
is when P is smaller than A,
P
right?
value greater than alpha.
Yeah,
if
Greater
you
than
fail
oh
to,
yeah.
fail
like
to
I
reject
said,
it.
yeah, there's that phrase in the video. He says, if the P is low, reject the null. To kind of remembering.
Yeah,
Yeah,
So
I remember.
failing.
I remember. So it will be when the P is lesser than alpha.
No, you want the greater than, because this one
When
is,
fail to reject.
yeah.
or fail to reject. Okay, when the little thing is pointing to alpha, then
Yeah.
okay, perfect. Okay,
Oh yeah, so number 9 would be the opposite.
the opposite.
P value less than alpha.
Yeah.
Yeah.
Okay. An insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim amount was $1,500. They are concerned that the true mean is actually higher than this. Use this information for the next two questions.
So which of the following would be the appropriate?
Which of the following?
Sorry, is my
No,
screen
no,
delayed?
you're fine. You're fine.
So we just have to find the appropriate alternative hypothesis.
Uh-huh.
So is it mu is greater than?
So it will be that the average claim is amount is greater than 1,500.
Yeah, because
Yeah.
they're thinking that. Yeah.
Okay. The average claim amount is greater than 1,500. Okay. Which of the following will be the appropriate null hypothesis?
The average claim amount is equal to
The
1,500.
average claim amount is equal.
Yeah.
Yeah.
Okay.
Excuse me.
Bless you.
Because that would mean that assumes the null hypothesis is correct. So that's why it would be equal to.
Yeah.
Okay,
Yeah.
sweet. The insurance company randomly selects 40 claims and calculates a sample mean of $1,650. Use this information to answer the next three questions. The insurance company assumes the distribution of the sample mean is normal. Is this a good assumption? Yes, because the
Sample
sample size is large.
Yeah, I think
Yes.
Yeah, it has to be greater than 40 to be large, right? I mean, like large enough.
30.
I mean, 30, I'm sorry, yeah, you're right. Sorry. What theorem of the law justifies this answer? Is that of the large numbers?
I think it's the central limit theorem.
Yeah, I think so too, because they talked again about that in here in this lesson. I think it was in the reading maybe. As it gets bigger, because the law of large numbers is it's closer to the population mean, right?
Oh, okay.
No, that's the. Yeah, that's the large numbers. Yeah.
So this would be the central limit.
Yeah.
Okay. 14.
Hang on,
Okay.
please.
Sure, no problem.
So, did you say the law of large numbers
Who, me?
No.
for 13? You
No, we
said
said central limit
CLT?
theorem.
Um, okay. I still have to keep looking at the definition of those two.
I do too. It's confusing unless you.
Unless you have them memorized, which is
Which we should, but
interesting.
I don't.
Oh yeah. That's yeah. I just found it. It says the sampling distribution of the sample mean will be approximately normal if the sample size is sufficiently large. Okay, yeah, your girls were right. Man, I had okay. Which of the following is the test statistic? Is the test statistic I've defined in this lesson?
Is it Z? Or wait, since we know we can use the Z-score to determine if X bar is far from the assumed value. This is called the test statistic. Oh wait, where Z is the test statistic. X. Okay, yeah, so it is Z.
Okay.
See?
Okay.
What is that at, Becca? What part of the lesson?
That was 4.2 under
Four
test statistic. Yeah, I just looked it up.
4.2.
Yeah.
Oh, okay. Indeed, since
Wait,
we
you
know
said the
the
Z?
Z, like zebra. No. Yeah.
Doesn't it say to determine the, what do you call the X with the line over it?
The average.
The X
The
average,
bar.
sample
So
mean.
they
the
call
mean.
it X, huh? Oh. It just in 4.2 it says towards the bottom it says where Z is the test statistic, X bar is the sample mean, and then mu
Oh,
is the population mean. And the O, is that the
the
sigma?
sigma
Yeah.
is the standard deviation,
Or
and the
yeah.
n is the sample. Okay, perfect,
Yeah.
perfect. Do you find that, Joe?
Oh, okay. Yeah, had I kept reading, I would have. I was
Okay.
looking at the paragraph above that.
I know, it
Oh,
was
okay.
hard to find until you got to the
That,
bottom.
Well, yeah,
that's only.
the Z-score to determine if X bar is far from the assumed value. This is called the test statistic. That's why I was thinking it was the X bar.
Yeah.
Oh,
I skipped over that last
oh,
paragraph.
yeah. That's what I told Stephanie. I was like, there are some things that are hidden that you have to like actually read the stuff again so you can get it. Okay. Number 15. The historical mean of sales receipts at a grocery store is 150, with a standard deviation of 40. The store manager suspects that the average has decreased. She sets up a hypothesis test with the hypothesis O mu equal 150 and mu is lesser than 150. She will use a level of significance of alpha equals 0.5. She then takes a simple random sample of 36 sales receipts from her store and computes the average of $144 per person, I guess. Uh, what is the C score associated with this test? Okay, let's do the math. think I'm doing this wrong.
So the mu would be 150, correct?
Yeah.
Yes.
Okay. And the variance, or what's the sigma would be 144?
The X bar is 144, so you would take this. Well, this is what I did. I would 144 minus the 150 up top,
Yeah.
right? And then you divide that by 40 over square root of 6. Is that what you
36.
did? Yeah. So divided by 6.
Divided by 6. Okay, okay. So it will be. Okay. So it will be 40 divided by 6 equals my molecular. It will be, wow. Is I get minus 0.90000.
That's what I got for the z-score.
Yeah.
So that's the answer that we type in there, right?
Yes.
Or do we have to use the tablet?
No, for 15, yeah, they just want the z-score.
You got 0.9?
Yeah.
Minus negative 0.9.
Do we have to put 900?
Yes. Because it
Yeah,
wants
just
3 decimals.
Yeah.
yeah. What answer do you get, Joe?
I got -1.
-1. Okay. So the formula would.
Did you do 40 divided by 6 for the bottom part?
No.
Because square root of 36
Okay.
is 6.
And then it's 40 divided by 6.
Okay.
Got it?
Yeah.
Okay, perfect.
So we have to plug this into the applet to get the p-value, right?
Yeah. Yeah.
For
What do
16?
we have to shade a certain spot.
Confused. Is it just the where do we see? I don't know where we shade. Does it have to do with like the greater than or less than thing?
It does. And it has it on the A.
So
if
it has to be less to the left, right?
I don't know.
well so in the reading it has the two-tailed as the two different sides.
Where
and
are you
then the
reading at?
left
What section are you reading at?
4.3.2.
Okay. Oh yeah.
4.32. Which one?
Oh yeah. 4.3.2. Yeah, so
Okay.
that has all the different graphs, so that's good.
So it'd be 368 or 0.368.
Oh, wait, so it's
If you shade both sides?
an equal one or a less than one, so that one goes with. So wouldn't it just be the left? It's a left tail.
It would just be the left.
Oh,
So see how it matches that those top two things?
Yeah.
Call them.
So did you get 0.184?
Yeah.
That's what I got.
Yes. So okay, guys, I have a question. So why do you choose the left side again?
Because in the reading it has all the 3 different options for two-tailed, left-tailed, and right-tailed. When it's two-tailed, you do the left and the right side. When it's left-tailed, you do the left side, and when it's right-tailed, you do the right in the middle.
And how do we choose which one is two tail or left tail? I think,
by
does
the
it say?
alternative hypothesis.
That was one of the, wasn't that one of the first questions? Let's see. For like question 5 and questions 6 and 7, they ask, right? Let's see.
On the quiz?
The information part, they give you the mu is equal to 10, and then for the next 3 questions, and they do the second one, and you have to say if it's left-tailed or right-tailed or two-tailed. Does that make sense? And then, so if it's equal or not equal, it's always going to be two-tailed. And then if it's equal or less than, like if the alternative is less than, then it's a left-tailed. And then if for 7
Oh,
equal
okay,
and then
okay.
greater than, then it's a right-tailed. Does that make sense? And then on the reading, it says how to shade if it's those different things.
Okay.
Does that make sense?
Kind of. I might have to
Memorize that, the
go.
shading, I guess. That's kind of confusing. So, okay.
Yeah, because I mean, because I remember that, but I was like, how do I apply that here? So, is it because we have the two questions here?
Yeah.
The
So,
new
yeah, the
equal.
ones in the information are right above 15. Do you see that?
Yeah, that says like.
And then the
new.
less than. So then that's a left-tailed. So then it showed on the reading to just do the left part when it's a left-tailed.
I'm still a little confused. But let's go. Let's go.
Explain it better.
Yeah.
I don't know. Am I confusing you? Do
Yeah,
you see? Yeah. Go. Do you see the reading? Do you have the reading open?
Yeah, I got the reading. Yeah, I got it. But
Okay.
how do you...
Where the left-tailed. So the middle one is left-tailed. Do you see that?
Oh, okay. So okay,
So the null is equal and the alternative is less than, right? And that matches what we are. That matches the combination in these questions.
Oh,
so that's
okay. Okay. Now I understand. Because I was like, why would you like? How do you choose that? And then and now that if they're giving in the question, then you use that assumption, right?
Yeah.
Okay, perfect. Okay, got it. Thank you very much.
So for 17, we would reject the null hypothesis, correct?
No, I think it's fail to reject because the p-value is 0.184 and the alpha was 0.05. And so it's greater than.
Oh yeah, haha. Yes.
Right, it's greater than the level of significance thing. Okay.
Yeah.
So if it's greater than, then we fail to reject. Is that what you said?
No,
Yeah.
Okay.
When alpha is greater than the number that we get, that's we fail to reject. Right?
No. When the p-value is greater than the alpha, we fail to reject, and when the p is low, we reject the null.
Oh.
So when it's lower than the alpha, then we can reject the null hypothesis.
Oh yeah, if p is low, reject the null. That's what you remember.
If the p is low, reject the null.
Yeah, so since the p was not low in this one, we fail to reject a null. Does that make sense? That's just what the guy in the video said to remember.
I thought that maybe my math is wrong, but I thought that 0.18 was less than 0.5.
It's 0.05.
Oh, 0.05. Oh, yeah, you got it. Yeah. No. Thank you. Okay. Moving on. It's 0.5. Okay, now I get it. That's 18, okay. Okay. So 18 would be, what is your conclusion for this problem?
We have sufficient evidence that the true population mean is less than 150.
I think we have insufficient evidence that the true population mean is less than 150.
Oh, this is so confusing.
Because insufficient means we don't have enough.
We have insufficient evidence that the true population mean is 150.
Hold on, I want to look at my note. Okay, wait, so if we reject the null, we have sufficient evidence. If we don't reject the null, or if you fail to reject the null, we have insufficient evidence to say. So that's what you just said, right? To the alternative? I think. Okay, wait, so insufficient. So wait, what's the alternative here?
That it's less than 150.
Okay, so we want insufficient and less than 150. Ready?
So we have insufficient evidence that the true population mean
less than 150.
Would that be the third one for you, Becca?
What? That's
Yes.
what. Yeah.
We have insufficient evidence that the true population is less than 50. Okay.
Okay.
Okay. There are two types of errors that can be made when performing a hypothesis test. Which ones involve rejecting the null hypothesis when the null hypothesis is true?
Reject the null as type 1.
Yeah.
Yeah.
Yeah. When we reject that true hypothesis. Okay. Yeah. You're right. Type 1 error. Okay.
A researcher decided that instead of using a level of significance of alpha equals 0.05, he will use alpha equals 0.01. Which of the following will be true?
So they were saying in a different one. So this is supposed to represent the percentage that. Hold on. Oh wait, maybe it's in. Might be in the preparation video.
I'm reading too.
Oh, so if you chose 0.05, you have 5% chance of rejecting the truth. So if you use 0.01, oh wait. Oh wait. But I don't know about type 1. I think that was type 1 error.
Mm-hmm. So it says, let me see. We choose alpha to be some small number, so the probability of committing a type 1 error is low. The most common value for alpha is 0.05. This is equal to 1, so 1 divided by 20. So when the null hypothesis is true, there is 1 in 20 chances that it will be rejected at the 0.5 level of significance. Another common choices for alpha include alpha equals 0.1 and 0.01. So maybe I think it's the probability that the null hypothesis is true will decrease. Because it will be like one out of 100 chances, if I'm not mistaken.
Well, the percent will decrease of rejecting the truth. So does that mean that I don't think that the true will. Oh wait. I don't know. Is it the
Joel,
last
in your
one? I have no idea.
I think Carlos is right. The probability of the null hypothesis is true will decrease.
That's what I'm kind of leaning towards too.
So should we go for that one?
Sure.
Let's go. Okay. If alpha is equal 0.05, compute the probability of committing a type 1 error.
So is it 5% or point? Is it point? Oh,
I think it's the same answer. I think, but I might be wrong.
0.05?
That's what I'm kind of
Yeah.
thinking too.
Because, I mean, what's the other probability? Like a type 1 error.
And it wants 2 decimal places.
yeah.
Or wants
Yeah.
2 decimal places.
I think that's right.
Yeah, because that's it. Like, what else? Like, I have no idea what else it could be.
Exactly.
I mean, unless he wants it in a fraction, then a fraction will be like 1
No,
over
it wants
20.
decimal.
I submitted the quiz already.
Uh-huh.
One of the questions is wrong.
Which one?
Do all of you want me to tell you which one?
Is it 20?
That
It's 20.
I
20?
kind of think it's the last one because the other two, I don't know. Because from 5% to go to 1%, isn't that's a lesser of a chance? So I think, I don't know. I would guess the last one.
What do you think, Jordan? I haven't submitted it yet, so because I was thinking about the last one.
I don't know. Let's see.
Are we using the same information or is this not it?
Oh, you know what? If you guys are reading here, the thing about type 1 and type 2, I would say that it has to do with one of the first two then.
Oh, yeah. So if the alpha value is very small, the probability of committing a type 2 error will be large. Conversely, if alpha is allowed to be very large, then the probability of committing a type 2 error will be very small.
Wait, say that again. So
if alpha is small, then the probability of a type 2 error will be large. And then if alpha is large, then the probability of committing a type 2 error will be small.
So the answer would be the probability of type 2 error will increase.
Yeah.
Oh, okay. Yeah, it's on the reading too, Becca.
where was that at?
4.5, and it's below the little
Chart.
chart exactly. Yeah.
Okay. I'm just gonna write that in my notes. So it's the second one. It's the probability of the type 2 will increase.
Yeah,
Yes.
I believe so.
Okay.
Okay. Okay. Let's submit and see if we got it right.
Got it right. 100%.
Yay.
Sweet. Let's see. Let's see. Oh,
Awesome.
awesome possum.
Yeah.
Man. Okay. This is awesome. All right, guys. Thank you very much again.
Yeah. So next Tuesday, do you know your schedule yet, Jordan, or you want to just?
I work in the morning, so 8 o'clock is good.
Okay, cool.
Perfect.
Awesome.
I'll be here too. 10 p.m. my time.
Yeah.
That's fine. I'm a night owl, so I'm sorry. All right, guys. See you
All right.
next Tuesday.
Have
All
a
right,
good week.
thanks, guys.
You too.
Have a good night.
See you. You too.
Okay.
Bye bye.
Bye.